our knowledge with proportions to apply it with something called similar figures. Vocab word that you need to know, congruent. If I say two triangles are congruent, two sides are congruent, two angles are congruent, congruent means same. Congruent is a vocab word for same in math. We like to say the word congruent. Similar figures are not congruent. Similar figures are proportional. They are the same shape, they're just different sizes. So, similar figures are proportional. Same shape, different size. So what I need you to know and make a connection with is what a proportion is. So if similar figures are proportional, it means you can create a proportion using similar figures. Okay? And if they're the same shape but different size, so like, I don't know, we can do a big right triangle is to a little baby right triangle. Or you could say little baby rectangle is to a littler baby rectangle. Whatever. Proportional means same shape, different sizes. Okay? One thing about similar figures have congruent angles. Congruent angle measures. That is the one thing. We don't use it much in 7th grade, but a lot when you get into geometry. Geometry like high school level geometry. Similar figures are not the same size, but what's interesting about them is even though one could be super ginormous and one is tiny, their angle measures, the corresponding angle measures, are always the same. Meaning if I had a rectangle that is as long as the school and one that is as long as my hand, they're all going to have corresponding angles that are congruent, the same. A triangle, a scalene. Right triangles are kind of easy to connect that. But think of a scalene where none of the sides are the same. I could have a ginormous scalene. I'll draw it for you. Let me just make a ginormous scalene. Okay, here's a ginormous scalene. Let's call this. Dun, dun, dun. And now if I clone this thing, wait patiently while I clone this thing. If I clone it and shrink it to a little baby, their angle measures are still going to be the same. Okay? So any similar figure has congruent angles. Congruent meaning same, not different sizes. Similar shapes are different sizes, but the angle measures are actually the same. So that was that little side note. Now, let's move on to proving that a triangle or triangles are congruent. So I want to know in this first one, is triangle ABC similar to triangle FGH? Okay? What? What did I do? Or you tell me the answer. Oh, what's the answer?
Yes.
But I want to know the process, though, please. That's what I really want to know. Now, because you have like 4 of them in the beginning of your assignment today, that I give you 2 triangles and I say, are they similar? Are they similar? If they're similar, this little line right here means similar. It's a little squiggly line. If they're similar, it means they're proportional. If they are proportional, it means their cross products equal. That's a C. So, let me just make that look a little bit nicer. So, if I give you 2 triangles, or 2 shapes, and I say, are these shapes similar? You need to check to see if they're proportional. If they're proportional, it means you can create a proportion and the cross product should be equal. Okay? For example, now there's so many proportions you can make with similar figures. My eyes look at A to B. So A to B is 8 as, now let's do the bottom, B to C, 12. 8 is to 12 as, then what should I do? Yep, as 12 is to 18. So I create a proportion and I check to see, well, is it really a proportion? And that's what we did in the first part of 6b. So does 8 times 18 equal 12 times 12?
Yes.
144 does equal 144. Yes, these two triangles are similar. You did not have to do 8 to 12. And don't write all this down or you're going to be writing a bunch down. What I'm going to just show you is you can use whatever proportion your eyes look at. The pattern is what matters. Notice that I did side is to bottom. Then I should have side is to bottom on the other one. So I went side is to bottom as side is to bottom. Okay? Or I could have said 10 is to 12 as 15 is to 18. Now it's different numbers, but if it's proportional, it doesn't matter. That means the cross product should always equal each other. So I can just go to 180. Does that equal 12 times 15? 180. Yep. That would have showed me it's proportional. Pattern is what matters, not order. So as long as you follow pattern. I could have went 18 is to 12. So I went big is to small as, now I should have big to small. I'll say 12 is to 8. 18 times 8, it's the same cross product, equals 12 times 12, 144. So, summary, doesn't matter which sides you use, because that was the big thing. Kids are like, well, which numbers am I supposed to use? I don't care. Whatever your eyes look at first is what I want you to use. The pattern is what matters. So, once you choose a pattern, choose it for the second proportion or ratio. Now, application. Why, in the goodness, do we learn about similar figures? Well, to find missing side lengths, of course. So when you want to find a missing side length, you set up a proportion and you solve it. And when I say set up a proportion, look at my cute little proportion template. That's what I mean. And don't forget, pattern matters. The pattern is the only thing that matters. There's going to be lots of different proportions. That's why when you ask me for help, I better see a proportion set up. I don't just look at an answer. And I check to make sure your pattern matches. Okay? That's the biggest thing. I want to make sure the pattern you are choosing matches. I'm going to do the most popular pattern that kids do, your age. The most popular connection, I always say, well, what's the first two numbers you look at? They say 13 is to 10. All right, no problem. Let's roll with it. 13 is to 10 means you followed a pattern of side is to bottom, didn't you? So I went side is to bottom, so I should have side to bottom as x is to 6. 10x equals, what would that be? 60 plus 18 would be 78. X equals 7.8. Okay? So, but let me just prove to you that order doesn't matter. It's the pattern. What I like to do, what my eyes look at, I like to say 13 is to x. That's just what's natural to me. 13 is to x, so I went big is to small as, now I better go to 10 is to 6, right? And then I should have the same cross product, 10x equals 78. Yep, that worked. You could have, let's say 10 is to 13. What did I do there? Huh? What did I do? Bottom is to side, right? I went bottom is to side as, now what? X or 6? 6 as bottom is to side. Tons of right proportions. Again, it's the pattern that matters. Last hour, I wanted to see an example of a round proportion with all these right ones. So a round proportion means you're not following a pattern. The first ratio should always be right. 13 is to 10. That's fine. That works out good. As, and then this is where they mess up. 6 is to x. So they went side is to bottom as bottom is to side. That is not a pattern. It should be side is to bottom as side is to bottom. Okay, so just be very, very careful with that. All right, next one. I need to solve for x. So I need to set up a proportion, one of many that can be set up. Okay, somebody give me a ratio. Zach.
6 over 7 is to
6. Where did you get 6?
4.
4. 4 is to 7 as
22 is to x.
as 22 is to x. That works. So he said small side is to small bottom as big side is to big bottom. Works for me. So then we get 4x equals 140 plus 14 will be 154. That's unit 4 mental math I'm doing with distributive property there. X equals something. What is it?
38.5.
38.5. Okay, now I'm going to pause the recording, but I want you guys on the left-hand side, where all your line paper is, make a wrong proportion. All right, now that we learned how to set up and solve using similar figures for missing dimensions, we are going to have combined figures. And when we have, it's called inner triangles, or else two triangles will be connected. What I want you to do is create a proportion with the two triangles. So anytime you have a shape that looks weird, you should be able to find two triangles in it. Okay, you should be able to find two triangles in it. And then the second thing you're going to do is solve. Remember, pattern matters. I keep saying that. There is not one right proportion. There are tons that are right. I want to say there's probably 4 or 5 that you can make. What matters is you're following your pattern that you choose. So, it should be some side is to some side as, side is to side, whatever you're choosing to do. All right, so can your eyes see the two triangles here?
Yes.
I have a big triangle. I'm going to go ahead and outline it. Now, you don't have to do that in your homework today if you don't want to. And I have a little triangle inside that big triangle. Now I need to figure out what the heck is x. So I can. I'm just going to pick a side. I don't care which number I pick at. 12. 12 is to, what do you want me to do?
14.
12, so Amelia sees 14. I think most kids see x first, but I like that. I like that 14. I'm going to do x first. 12 is to x as, so I said big is to small as, now what goes on top?
The 10.
It's not 10.
14.
Because think about it. Did my triangle stop right here, my big triangle?
No.
No. My big triangle goes all the way across. So as 14 is to, what's my small triangle? 4. So I said big is to small as big is to small. 14x equals 48. X equals something.
3.4.
Okay, you're going to run to nearest 10 today? Alright, so again, remember that this bottom, if you did 12 is to 10, you think that the triangle ends right here. It is the most popular mistake that kids do. The big triangle goes all the way across, which means the 10 plus the 14. You'll have one like that that tricks you. One more thing on the left-hand side of your notes. I want you to copy this triangle down. Watch me go. Here we go. Okay, I'm going to redraw that. Actually, I don't like that one. My notes are going to end here, but that's okay. Okay, I'm going to get rid of that. Okay, so we go up, over, up, over. Okay, do that. Do you see two triangles?
Yeah.
Same. But now you don't know what to do with them yet, so don't do anything. And then I want you to make your right angles. Right angle, right angle. And I want you to make your vertical.